All right, so this is exam 1, part 3 of problem B. What it says is derive an expression for the inner and outer surface charge density of the conducting shell only in terms of given quantities and fundamental constants. So, what we're looking for is the charge density of this outer part of the shell and then this inner part of the shell. Now, how do we do that? Well, first, we know that, so we're not necessarily dealing with this insulator shell that's in sphere that's in the middle here. However, it's important to know that it's a positive 2q charge on the inside. Now, on the outside, and I'll go over that why that's important. Well, on this outside shell, the overall charge is negative 3q. But remember, this is a conductor, and so the charge exists on the outside of the material. And so this negative 3q is going to split. It's going to have a negative 2q on the inside, so I'll write that here. So it's going to have a negative 2q on the inner surface, and then it's going to have a negative q on the outer surface. And that's because the positive 2q here is going to attract the negative 2q, basically the same amount of charge on the inner ring of that. So now we don't necessarily need this. We don't need this sphere anymore. But just know that's the reason that it's important is that it splits the overall charge on the conductor on the outside. Okay. So now that's settled, we can just focus on, we know that the inner side of this ring, the charge is negative 2q, and then the outside is negative q, the overall charge. So, some things to note. Surface area is equal to, of a sphere, is 4 pi r squared, radius squared. R being the radius. Now, charge density is equal to total charge divided by the surface area, or the area of our shape. So in this case, we want to find the charge density for the outer surface. So for the outer surface, the total charge for the outer surface, remember, is negative q. Negative q. Divided by, well, the surface area of this sphere is going to be 4 pi. Instead of r, our radius is c, right? Our radius is c for the outside. So it'll be, so if I redraw this, it's negative q over 4 pi c squared. That's for the outer. That's the outer charge density. Now the charge density for the inner portion of this shell is, well, remember all those negative charges moved towards the center, so it's negative 2q over 4 pi, and in this case our radius is b, so b squared. Yep, and that's it. Ooh, that was an easy one. All right, cool.